Example 4 from section 12.1 says show that 3x squared plus 3y squared plus 3z squared minus 6y minus 12z equals 10 is an equation of a sphere by writing in standard form and identifying its center and radius. So first of all, the equation of the sphere is given up above here. You do need to memorize it, however. H, K, and L are constants, and so is r squared. So once we write it in standard form, we'll be able to easily identify the center and radius. Going back to our equation, notice we have an x squared, y squared, z squared terms, and then we also have a y and a z term. So what this means is that for the x component here, or the x term, x part of this equation, h is going to be equal to 0 because we don't have that x term. Sort of similar to in the extreme case here where h, k, and l are 0, then that equation of a sphere reduces down to x squared plus y squared plus z squared equals r squared. So anyway, going back to this, the way that we get it in the standard form with the parentheses and the squares is we have to do something called completing the square with any of the ones that have their counterpart that's just the variable not squared. So in other words, this one's got a minus 6y and a minus 12z term, which means we're going to have to complete the square for the y's and the z's. X, we can get away with not doing it. So the first step is to collect all your similar variable stuff together. So 3x squared is all on its own there, but then when we start writing with 3y squared, we want to bring up minus 6y. So they're together, and then we can write plus 3z squared minus 12z equals 10. So completing the square, a quick review on that. Generally when we have something of the form, and I'll just use x because that's kind of the standard way, we have x squared plus bx. So if you replace the x's with y's, that's what we got going on here, except we got a coefficient of 3 out front. But we have kind of like a y squared minus by, or plus b y thing, or x squared plus bx. So when you have something like that, you can do what's called complete the square. So you're trying to get something in parentheses of the form x plus whatever. I'll just use C there to be generic constant squared. And that's what we're trying to do. And so what you do is if you add b over 2 squared, that would complete the square, or in other words, you can factor that into a binomial squared. I'll show you that in a sec. But to have it be equivalent to the expression x squared plus bx, you have to have that negated by subtracting that same term. So the completing the square part is now we're going to take this and we're going to factor it into a perfect square. So what that's going to be is x plus b over 2, that quantity squared. And then it looks ugly, but the minus b over 2 squared thing is just a constant, and we're going to be able to take care of that at the end and include it with the radius on the right. So that's not going to cause us any problems in the long run. So now that we have that review, a couple things. Notice this one we got a coefficient of 3. It's not just y squared, it's 3y squared. So this was what I meant when I wrote we have to have that going on with regards to not having a coefficient other than 1 in front of the squared term. So the way that we're going to correct for that is we're going to factor out a 3. Then we can just look at what's in the parentheses and focus on that to complete the square, and everything will be alright. While I'm at it, I'm going to do that also for the z part, and it also happens to be 3. So factoring that out, we're going to have 3 times the quantity z squared minus 4z equals 10. Alrighty, so next up, we're just looking at the y squared minus 2y. Our b is negative 2. And so what we want to add and then subtract is negative 2 over 2 squared. So that's negative 1 squared, which is 1. Let me add what I was saying in words to make that clear. So we're going to have to do this as well for the z's, so let's just work on this at the same time. The b over 2 squared for this part is going to be negative 4 over 2 squared, which is negative 2 squared, which is 4. Now the reason why I'm bothering writing, for example, negative 2 squared, is that if I write it that way in this next step, when I'm actually adding and subtracting that term in there, notice that it's going to help me factor it, because that b over 2 is actually what this factors to. So if I simplify it to 4, you might lose the negative, in other words. So just a tip there. Alright, here we go. Next thing, 3 parentheses, and then we have y squared minus 2y, a little silly, but we're going to write it as plus negative 1 squared. And then if you want to write it as minus negative 1 squared, just to kind of show that they're the exact same thing, or if you want to just write minus 1, that's fine. So we're just adding and subtracting the same term so we can complete the square in the next step. Doing that for the z stuff, we got 3 parentheses, and then we got z squared minus 4z, and then we're going to add negative 2 squared. I'm just going to write minus 4 here to show that style. Then finally equals 10. Okay, completing the square step, I'm going to show some little notes here to highlight it. This is where we complete the square with this part, and what this becomes is y minus 1 squared. So see the minus 1 here turns into, or the negative 1 turns into minus 1 here. And then we still have the minus 1 over here hanging out on the outside. So I'll write that in a second. Okay, now doing it, 3x squared plus 3, I'm going to use some square brackets. Then we have another set of parentheses, y minus 1 squared, and then that quantity minus 1 in the parentheses. Next one, plus 3, completing this square with a z. Oops, I'm going to use my square brackets, be legit. And we have z minus 2, that quantity squared, then minus 4 in the square brackets equals 10. We're getting there, trust me. Now, we got extra brackets here, but you can hopefully appreciate that, hey, we got those parentheses with the squared. That was the hardest part. So now we're just trying to finish this off and make it look like the standard form. We had the hard work out of our way. We're going to distribute the 3 here now. Not inside the square, just to each of these terms to clean this up a bit. So we have 3x squared plus 3 times the quantity minus y minus 1 squared, and then we have minus 3 without the square brackets, plus similarly 3 times the quantity z minus 2 squared, distribute minus 12 equals 10. Now we have some constant terms we can get rid of. So notice we have minus 3, minus 12, which together are minus 15, and so we can add 15 to both sides. We have 3x squared now, plus our other junk. We'll sum it up as that. And we're getting really close. Careful though, in our standard form, we do not have coefficients in front of those squared terms. In other words, there's no 3's in front of all those. That's not accounted for. So notice we can just do one step here one false swoop, we can go ahead and divide both sides by 3. So doing that, distributing the division by 3, we would have x squared plus just y minus 1 squared plus z minus 2 squared is equal to 25 over 3. So believe it or not, this is in standard form, and we got that task completed. Next thing is identifying the center and the radius. So the center is at h, let me scroll, HKL, and it's minus. So here we have minus 0 for the x, so 0, 1, 2. If it were plus there, you'd have to make it minus a negative and report a negative for one of the coordinates. The radius, remember it's r squared, and so on the right side, and so this is going to be, if we take the square root, we're going to have 5 over square root of 3, which good enough, but if you want to be real fancy and simplify here, no root in the denominator, in other words, we can multiply by square root of 3 over square root of 3 and get 5 square root of 3 over 3. So, looks good, and we're all done.